Cool. So guys, we really wanted to hear from you. I think there's not many external participants today, but whoever is around, um, if you can tell us, right, where you are, how are you thinking about this, any ideas you want to bounce off us, any issues you're facing, yeah, that will be good.
Okay, if no one else is speaking, can I say
Hmm.
something, ask
Sure, sure.
something?
Yeah, yeah.
Okay, so there are, I think, a few things that might help us. I'm not actually participating in the competition, but I'm just asking. I have been
Hmm.
exploring. So,
Hmm.
um, there are suppose if we wanted to simply check the list of places or hierarchy, how the data is arranged, or how the villages, which villages fall in which tehsil, or these kinds of basic things. Suppose someone were to simply check his own village or his or her own village, what is the status there, or what there is no pathway available. I
Mm-hmm.
think the IDs are not um, simply accessible in one place. There is a API call that I can see, get all tehsil or get all active places.
Hmm.
So I could extract from that, but that is state, and then district, and then block level. Um, it is, and then but the main hierarchy level in other implementations is state, district, and then tehsil. So it gets a bit confusing, and then one has to get from tehsil directly to villages. Also, there's one more thing, that the um, stack layer, is, uh, the layers that have been uploaded on stack, um, their names are not suppose if we were to extract a whole bunch of things from that, the names are not harmonized. So, and there's no pipeline available in the backend um, code that was provided earlier. So, if I were to say, suppose extract data for extract all layers available for some particular tehsil, you have to go to the stack website and then create a scraper through which you can do this. And the names are again, because there is one name for one kind of naming pattern for the file names, and then different a different kind of naming pattern for um, the style files, QGIS style files. So that has also been a bit of friction. Um, Apart from that, yeah, I'm just waiting for others' questions.
Hmm.
Um,
Cool. Yeah, no, those are very important points, Amit. These are definitely things we need to improve. Um, I'll respond a little bit on some of these, but let's also, I mean, other people, or if you have more
yes,
points,
yes.
then, let's go ahead. Um, Anoop, do you have any questions?
No, I'm actually joining for the first time.
Okay.
So I'm just trying to understand how the whole setup works. Uh, I saw on LinkedIn some of the challenges, and like a couple of them seemed interesting to me, but I'm not sure how one goes about joining it. So I just joined to understand how this thing works.
All right. All right. Yeah. Cool. Um, Great. Uh, Fine. So, Amit, let me give some quick responses, and but definitely this is very good feedback. Um, So one thing is that block and tehsil, actually, these are just a naming error that we've probably not fixed everywhere, but we basically, it means the same thing. And technically, these are different, but in the code, actually, everything is a tehsil. Wherever we've mentioned block, that's actually something we need to fix. Um, uh,
Okay.
yeah. This then about the stack names not being harmonized, yes, definitely that we need to fix. Um, and but there is also this API, get layers API, which also basically returns a JSON with all the layers in it. So you need not scrape from the Stack website or use some of the Stack APIs. That will also be useful. I mean, that will also be great if you want to do that. But it need not be like that. You can invoke this get layers API, um, which
Okay,
does
I
return these
thought
things.
I checked that Python script.
Hmm.
So I thought that that was meant for GEE layer extraction. So I didn't try that. Okay, sorry.
No, no. Actually, I mean, what it basically means is that we've not done a great job at explaining and defining some of these easy starting points. Um, we have covered it in some calls, right? But it's probably not easy. I mean, like we can't expect everyone to have gone through all the recordings and right absorbed all of it. So yeah, I think some of it we should be putting up cleaner documentation so that it's easier for people to just get into the system and use it. Um, and yeah, same with style files. I think the naming and everything should definitely be fixed. Yeah, cool. And just go ahead, right? Any other points you've come across which you think we should improve?
Um, Currently not. I'm just waiting for other queries. If anyone else has, then
Actually, I think most of the other folks are from our team only. Uh, so
okay.
today we don't have many participants from outside.
Um, okay, so I also had few more questions. I haven't actually noted them down. I was working on some of them. Um, there are actually a lot of layers when we get down to it, like in the stack. There are a lot of layers, and there are many more layers. A lot of data has already been computed, and I didn't get to know about that without fully exploring it. So I'm just getting to know and checking all of them at the moment. I will actually pose some questions maybe a bit later,
Hmm.
but
Hmm.
they haven't
Sure.
been formalized at the moment.
Hmm. Sure, sure, sure. Yeah. Cool. Okay. So let me share my screen. I'll let me talk about a couple of points. Um, yeah. So, oops, I didn't want to do that. How do I close this thing? Um, uh, and this is definitely for new folks, right? So if you go to the CoStack website, go to news and events, and right, this is the main challenge page. So it'll be great to. So there's a lot of background information that we've put up over here, and it will be great to go through this. This is exactly the part that I think we need to simplify even further, like what Amit is also pointing out. So this thing describes the data structure, right? The conceptual data structure to expect uh, yeah, that how is everything organized in the stack, right? That in terms of the hierarchy of basins, subbasins, watershed, micro watershed, and water bodies, and so on. So all the data is basically being pre-generated for all of these things. Yeah. Then likewise, we've put up a couple of notebooks which explain how you can invoke these APIs. Yeah. So so these APIs again, probably we need to make it simpler for people to get on. But like this get active locations API returns a list of tehsils for which data has been generated. Yeah, and we can do it on demand. It takes us a couple of hours to generate the data for any tehsil. Um, right, so that's how it goes. Right, then this get layers API returns a list of all the layers, right? So in case you want to pull data from the layers, then this is one way to do it. Another way is to also pull them from the stack specs. But over there, we've actually not put out any notebook so far on how to go down that pathway, but that is also another option. Um, yeah, then some data is of a time series nature. So in each micro watershed, you can get a fortnightly time series of rainfall, runoff, and evapotranspiration. Right. So this one is useful. Similarly, get tehsil data. This returns again a very detailed information. Right. That um, for different for any micro for all micro watersheds in a tehsil, it returns right information that you can see that for that micro watershed, right? What is the total area? How much area was afforested, deforested, degradation, improvement, and so on, right? So these kinds of things on tree change, and so this is really one of the main USPs in some sense of the core stack, that we are pre-computing a lot of this data. So literally, it's just a matter of raising an API, and all of this data is on your fingertips, and you can then do a whole bunch of analysis or whatever you want with it. Yeah. So yeah, so over here again, some of these videos explain how you can do some simple analysis, like right. I mean, get this data, build probability distributions, do scatter plots, see right how whatever cropping intensity varies with water balance and so on, right? So these things are very, very quick to do. Similarly, you can also pull data. You can build interactive maps. Like over here, we showed how you can build a map of that for any area. You can see how different micro watersheds flow into each other. Um, all of this is pre-populated, so there's data that we're showing on how tree cover is changing over time, what is the kind of deforestation that area has seen, uh, what is the kind of runoff and rainfall in that micro watershed, and so on, right? So all of these are very straightforward to do. Then we also talked about some ideas that other organizations have proposed, right? And in one of the videos last time, actually, we went through a lot of ideas that we had also put up on the challenge page, right? So over here on this detailed page, we had we explained in that video a lot of these ideas of interesting things that could be done. Plus, other partners have also proposed a bunch of ideas on building, like we don't have water quality data on the core stack right now, but INREM is eager to work on that. Um, uh, Kaustubh is a faculty at APU. He's been working on analyzing the ecology around lakes. So on the core stack, we have all of this information that we're monitoring of how um, uh, area underwater has been changing in different water bodies over time. and other characteristics. One of the ideas is to also pull in information from citizen science platforms like eBird and iNaturalist kind of platforms. Um, and Another colleague, Madhura, has been wanting to look at that there's data on reservoirs and canals. Can we sort of follow the canals and build a command area map of the canals? And that could again be used for interesting analysis, like what is the cropping intensity in the command area? How has it changed over time as compared to areas outside of the command area, right? So a lot of that is also there. Um, uh, uh, so eh, there's also two things I wanted to talk about today. One is an additional proposal by Arakyam on building a grey water management tool, and then another one on protected areas. But before that, let's again pause. If there's any questions, yeah, we can uh, take those. Okay.
Okay.
Uh, yeah, go ahead.
Okay. During my work at like my previous work, and also based on like general observations, um, there's a basically general pattern in Indian like
Go ahead.
in
I'm just
Indian
scrolling. Sorry. Go ahead.
villages like that people of certain communities live on the like periphery of villages, right,
Mm,
and
mm,
some
mm,
people live within the center of it.
mm,
So I was just trying to actually in the previous work I was trying to map it in a way, or like try to infer it, or like try to prove that uh, it was the case. But is there any data set that do you have in mind that can suggest this, or have you looked into it? Actually, these I have been looking around canal area. This third proposal also. You last time you talked about it. So I am working on this also, but this is just another question that I had in mind.
mm, mm,
I have been trying to work on this.
mm,
Um, but in case you have any suggestions that I could follow, or
mm. Yeah. Yeah, so actually, that's a very good question, Amit, on inequality, right? So actually, there's no data, easily available data on that, because here we are really talking about how resources are distributed inside villages, right? That which
yes,
communities inside villages have what kind of resources and so on. But actually, uh, uh, I'll in parallel see if I can join through my phone. Um, so on Commons Connect, which is this other application that we've been building, yeah. So
yeah,
what we've really been talking about so far for the core stack is um, I mean, on these calls, largely what we've talked about is this kind of an architecture, right, of the core stack where we've been talking about all of these different layers that we've pulled in or generated, and then indicators that we've made available, and these can be accessed through APIs, right? What we've not talked about so much is that we are using the same indicators and APIs to build these applications, yeah. Know Your Landscape is a web-based dashboard, and Commerce Connect is an application. It's an Android application meant to be in the hands of people from the community. Yeah. So in fact, I'd maybe Ankit or anyone, right? Maybe you guys can show a quick demo of Commerce Connect in a little bit. Um, So in Commerce Connect, actually, that was one of the main reasons why we actually have a mandatory settlement by settlement mapping process. So what we advise people who are using this application for NRM planning, natural resource management planning, is that you should basically go settlement by settlement. In each settlement, the app requires you to identify what water bodies exist, what wells exist, who owns them, who uses them, right? And we will soon be building new screens on Commerce Connect that, based on this information, what is the overall equity in this village? Yeah, that are there some groups who have very less access to land, less access to water resources, right? Whereas some communities have more access and so on. Um, uh, so that data is, however, not available like pan India or anywhere, right? It's only where Commons Connect is being used. That's where this is new primary data coming in. Yeah. But it'll be interesting to
Okay.
potentially, yeah, once a lot of such data is available to analyze it, and yeah, it'll be interesting to do that.
Yeah, I'm just glad कि there's some place that it is getting
Mm,
generated.
mm,
So
mm,
later on I can talk about this, like work
mm.
on this also.
Yeah,
But
yeah,
currently,
yeah. Actually,
thank you.
maybe if this thing works, so one of my PhD students has been doing something similar, but at the panchayat level. Yeah. So she has built uh, this application using data from
Yes,
Narega.
I have checked that. Yeah, yeah.
Okay. Cool, cool. Yeah. So this thing, basically, what it does
It,
is that, let's say,
Bihar Jamui.
yeah, actually, if we, maybe we can on ST, if we go to Jharkhand. Um, So what it ultimately does is that it uses data from Narega on how much allocation has been made in each panchayat. And Narega allocation data also is, I mean, it's easy to analyze it at a panchayat level. Below panchayat, it's not. I mean, then the data is not
Yeah, yeah.
published at a village level, unfortunately.
Mm.
Um, so what? Uh,
How did you get
hmm.
these geo points? Sorry.
No, these are basically just panchayat bound. These are block boundaries, and within that panchayat boundaries, but maybe they're not coming out very. I mean, maybe they should have been made out more clearly, but this is probably a panchayat. Yeah.
Mm.
Um, and so these things basically we see how much allocation was made in a panchayat, and how does it compare with a very similar panchayat, but where the SC/ST population is where it is more of a general category panchayat, yeah, rather than
Okay.
panchayats with a significant SC or ST population. Yeah.
Yeah.
So essentially for each panchayat we find a counterfactual panchayat which is very similar on all parameters except the caste composition. And then the difference then tells us that the differences, therefore, can be attributed to the caste. And yeah, and then there are many other variables that we use to see that what could be the reason behind some of this. That right. So there's some heuristics that we use to see that whether some difference could be just because of local elite capture, right? So meaning that across panchayats there is not a lot of inequity in distribution, but within the panchayat, uh, some castes are general caste is getting much more than SC/ST. Yeah, so we say that that's probably local elite capture. Um, Administrative discrimination is if across panchayats, some panchayats are getting more than others, right? So that could be just because of how the allocation is being made, right? That SC/ST panchayats are not getting as much as general category panchayats. And then this is like a combination that both things are happening. So it's a way to then potentially do more precision policy that right, maybe in these areas there's some corrective allocation that needs to be done. Maybe in these areas there's more awareness or community mobilization that needs to be done. Yeah. So that was the thinking behind all of this.
I've been actually looking for the Python script or the GitHub repository for this particular paper, and it was not available, so I couldn't figure it out how um,
Mm,
exactly. Actually, the paper points it out how the algorithm, but this local elite
mm,
capture and the
mm,
difference between administrative discrimination, how you compute that, I haven't been
mm,
able to
mm.
check. So if the
Sure.
script could be
Mm, mm,
added to the backend
mm, mm.
um
Yeah,
GitHub
yeah, yeah.
repository.
Actually, you can just write to me or Ashima, and I anyway I'll remember to pass it on to you. Yeah, I mean this we've not pulled into the core stack as yet, so that's one thing. This is sort of more just work that the students have done. It's not like integrated into the core stack as yet, but we can get to it in due course.
Okay,
Yeah,
okay, thank you.
but we can definitely share, whatever form the code and data is in right now.
Yeah,
Hmm. Okay. Cool. So let me then also talk a little bit about these two new ideas. Yeah. So one is a tracker for protected areas. So what the team at IT Bombay has done is that they've mapped over 500 protected areas across India. And then for any of these areas, they've also collated news articles that have been written about this protected area, right? So it's more of the group over there is looking more at news coverage of protected areas. Yeah. But they have these polygon boundaries. Yeah. So what we did is that in the core stack, we had computed maps of this sort, right? That which show that across India, where do we have changes in tree cover? Yeah. So things like this, right? That where has tree cover increased or decreased? Right. So tree cover loss and tree cover gain is that there was a tree earlier, but now there's no tree, right? Tree cover gain is right. New trees have been added. Degradation and improvement are further finer classes that has there been a change in canopy density or tree height? Yeah. So these are now finer things that has a canopy density improved or not, and similarly the tree height, right? So the trees are still there, but maybe the density has reduced or the height has changed or something. Yeah. So uh, right. So one of the things basically we did was just a simple Google Earth Engine app, which takes those protected area boundaries, right? Here they're showing polygons, but they actually have, sorry, they're just showing the points, but they actually have the polygon, which they shared with us. So we took those polygons and we were able to intersect those polygons basically with the Pan India maps that I showed. And then if you click on this, then these are just the stats that we computed. Yeah. That how much area has seen no change, how much has improved, and how much has been the degradation. Yeah. Um, in this particular right wildlife sanctuary, and then further a couple of news articles that have been collated about that. Yeah. So this computation was basically done on Google Earth Engine only, where we take this kind of a raster map, right, that what exists in this area, and we intersect it with this polygon, and then we basically count, right, how much area is under which kind of a change class. Yeah. So that is that's what helps us do these computations. Yeah. So this was another example that uh, just to put it in perspective, right? We showed how some of the pre-computed data can be accessed to APIs. Some of it can also be pulled in directly through the layers, right? By getting the layers, downloading them, and then processing them. This is an example where we can write Earth Engine scripts or applications to process the data. Yeah, because everything is at different stages of development. So over here, for example, there are many layers that we have on the Earth Engine, but we've not brought into the APIs as yet. Yeah. And similarly, some of these layers have a lot of data embedded, but not all of it is exposed through APIs. So, so we just wanted to give a complete overview of how, from different data sets, different methods can be used to pull data. Yeah. Uh, so that was one thing that I wanted to show. And here again, there are many more ideas, right, that can be done. So there's this uh, right more metrics like fragmentation that can be computed, water availability inside these, right? So again, a lot of the layers are available. So water availability again, right? Basically in the LULC that we have, right? Over each year, we know, right, where is water available, and then like in 2020, how much of this is perennial water, right? Dark blue. How much of it is seasonal water, which is this lighter shade of blue. Yeah. So a lot of these things are there. So that can also be looked at. Yeah. um, Land use changes, for example. Yeah, then you can even analyze the text of the news articles and see if the news articles are saying anything about some of the tree cover changes that might be happening. Um, then uh, another interesting idea can be to pull in biodiversity information as well from platforms like eBird and iNaturalist. Yeah. So that will be quite interesting. Plus, because now here basically there's data of almost 600 protected areas, right? So all sorts of interesting analysis can now be done. Yeah. All the data is already there. It can be downloaded as a GeoJSON, right? And it's not too big, couple of MBs of GeoJSON only because it's already pre-computed data, right? So all sorts of interesting analysis can be done that how are these protected areas faring across different states or across different ecoregions. There's also different types of protected areas. So some are wildlife sanctuaries, some are tiger reserves, some are wetlands. So again, right, each one, how are they performing as a category? Yeah, a lot of that kind of work is very straightforward to do. Yeah. Um, Then the other thing we wanted to also quickly talk about is this proposal from RKM to build a grey water management tool. Yeah. So here, what RKM has basically suggested is um, right where to locate grey water treatment systems. Yeah. Now, if you look at this particular question first, the idea is that. Uh, uh, you probably now where to situate gray water treatment systems could be dependent on terrain, right? Is it close to drainage lines or not? It could be soil type might play a role that you want it to be on soils um, which are not so permeable so that you can treat them, but pollutants don't go into the groundwater. Yeah. Or is the groundwater already has some pollutants in it already, right? Is the area flood prone or waterlogged, right? What's the land use, land cover, and so on, right? So one common way in which uh, such kind of uh, indications can be built is that actually each of these is a different layer, basically. Yeah. And you want to assign a suitability score that if terrain is of a particular type, or distance from a drainage line is within something to something, or the soil is of a particular type, yeah, then you keep building up a score, right? And you can say that, well, if like 5 out of 7 parameters are suitable, then you say that that location is suitable. Yeah. There can be also interesting ways on how to do a weighted average. Yeah. So there's right, and experts can also be called in to assign these weights. You could right, ask a panel of experts to assign these weights, and then figure out some consensus between them. So many such things can be done, and Aragyam is one of the leading organizations in this whole space of water safety. Um, and water access. So they have access to that technical know-how. Yeah. So it is actually just very, very similar to this, that we also built a uh, agroforestry suitability layer. Actually, we didn't. I mean, in the sense that this is a paper that we've basically implemented by researchers who worked in the Northeast, right? So they do a very similar thing, that based on certain climate parameters, is there a better? Yeah, right. So they built a score based on a bunch of different layers, that they have suggested ranges of evapotranspiration, ranges of aridity, temperature, precipitation, right? And based on each of these, they've built different weights from which they assign a weight on how suitable is the climate of that area for agroforestry plantations. Yeah. Similarly, based on soil, different soil properties, right? How suitable is the soil? How suitable is the topography? Uh, the overall ecology, socioeconomic factors like distance from roads, distance from settlements, right? So they use all of these, and they right. So this is one of what one of their tables that it would look like, right? That so they've assigned basically scores, that if the precipitation is more than 2000, right? Very good, good, moderate, and so on, right? So, right now, they built up these scores in a particular way. But the idea is that if these scores are there, then building such a composite index or a composite suitability score is quite straightforward. Yeah. So that's what Arikyam is suggesting, that actually a lot of these layers are already available either on the core stack, or it's not been pulled into the stack as yet, but it's available publicly in other places. So this can be used to identify areas which are suitable, not suitable, conditionally suitable with safeguards. Yeah. uh, so that's one of the things that can be done. Yeah. The second point is that what kind of a treatment technology should be adopted. Yeah. And this again, right, you don't want to, of course, just be sitting on a desk and do all of this. But some of the input parameters can be from secondary data, like these kind of geospatial data sets. Plus, additionally, you can input some data about that location. Yeah. So here you could be looking at things like, right, outputs from function one, which is the site suitability. How suitable is that particular site? Plus some other parameters which engineers or CSOs or anyone working in that area can provide, right? That um, um, uh, what is the actual right population, for example? Perhaps based on the population, you can get some gray water generation estimation also. How much land area is available? Right? What is the climate rainfall variability? This can potentially come from secondary data, right? Groundwater contamination risk and so on, right? So this again can, right? Arakyam has access to that expertise, who can then suggests, right, how all of this data can be combined into what they're calling a function, right? A function to select the appropriate gray water treatment technology. Yeah. So these things can be quite useful because it can bring more systematization to the whole decision-making process, and also bring transparency in the process, right? Of course, this is not to say that the recommendations coming from the system, right, will always be very correct. But it can always be countered with more information about the actual reality in the area, right, or the actual need for such systems in the area. But it can at least start introducing a more systematic way of planning of such things. Yeah. So yeah. So yeah. So I mean, there's a lot of such information that we've been putting out, um, and right. So this is really the main page that anyone wanting to learn more can start from. Um, yeah, but I think all this feedback from you, Amit, is very, very helpful, because I mean, it basically tells us that a lot of this we started doing with the challenge itself, but there's a lot more we should be doing to make it easier for people to start using the data and to build new innovations and stuff on top of it. Um, So yeah, and again, right? Any questions on any of this? Okay, so let me also then have Ankit or anyone else from the team. Can you give a demo of the of Commons Connect also? Yeah, I think we've seen Know Your Landscape a bit earlier. Uh, yeah, Kshitij, you can go ahead. Your voice might be breaking though. Just see if you're in a good network. Kshitij, your voice is breaking.
So Kshitij is joining in a moment. He's changing his network.
Okay. Yeah, Amit, basically all the links are from here, the CoStack innovation page. Are you able to
Yes, sir.
basically, yeah. Hmm.
Okay, they are already there.
Yeah, all the links are there. Um, and there's another question that there's a UID column. Yeah, so UID is the micro watershed ID. Yeah. So again, if you go through this link, specifically the blog, one blog is about understanding the data structure, and one blog is about the Pan India Micro Watershed Registry. So these two blogs will be very helpful to understand what this whole micro watershed architecture is about.
Also, I just wanted to ask if the UIDs of villages are same as 2011 census
Hmm.
records, um, or like shrub
Hmm.
records.
Hmm. Yeah, both the IDs are there. Yeah. So the boundaries come from Shrug, and then so the Shrug ID is there, and then the 2011 village ID as well as the corresponding 2001 village ID. Both are there
Yes.
in the data.
Okay.
Boys, is Kshitij or Ankit able to join, or should I
Yeah, yeah,
can join in?
yeah. My voice is audible, right?
Yeah.
Yeah, so I'm sharing my screen. One
Okay.
second.
Yeah, try now, Ankit. I think it wasn't shared. Permission wasn't given earlier.
Yeah.
Mm.
Mm. Uh, use share. Yeah, so my screen is visible, right?
Yeah.
Yeah. So, like, this is the home screen of our application. Like, basically, you have to select state, district, and tehsil. And for a given state, district, and tehsil, we show the layers and option to add resources and raise demands or maintenance. Okay. So let's go into. So basically, like first of all, like users, uh, like the CRPs go into a certain village. So they raise a request to create a plan. So basically, we create a plan for that village, and then let's say like there are certain number of plans in. So these two organizations are working in CoRE. So basically, like there are some certain test plans also there. Okay, and this is the base map which we show, and these are the resources that has been marked for that plan, right? The yellow signifies that the resources marked requires maintenance. Right. So like there are two sections of the application. One is resource mapping, the other is planning. In planning, we basically raise demands or ask for maintenance for existing resources or for any new resources, right? Right. And in resource mapping, we can add certain things. I'm sorry. Yeah. So we can add basically settlement. Like basically, you can put a marker over the map and add settlement. So there are certain set of questionnaires which we can fill. Yeah, there are certain languages also, like this is custom. Uh, so there are certain set of questions which are which needed to be filled in the field, and upon a successful submission, uh, a settlement is added. So let's say this is the sample settlement. This is a test plan basically. So this is a sample settlement. For a settlement, we can add certain things like wells, water structures, cropping pattern, etc. So these are basically like we are marking resources for the settlement we added, right? So if we click on mark resources, then we can add uh, wells, water structure. So basically, like you tap on the area and a questionnaire, a form will open. You fill the questionnaires and water structure or well is added, right? Next. So this is the cropping pattern. Once you click finish, you can get the confirmation and just to get back to the home screen. In the planning section, we have certain different kind of sections. That in groundwater, we basically talk about recharge structures. In surface water bodies, it's all about surface water body or remote sensed surface water. In agriculture, we have LULC maps and all. In livelihood, we capture the data for plantations and sorry, basically like yeah, kitchen garden, etc. In livelihood. In agro horticulture, now we are capturing the plantation part. So let's go one by one. Right? So in the groundwater, we can see the map is basically the water balance. Shows the water balance over the last 5 years. Right? Um, so the like the color signifies that how what is the depth of the water balance, right? How much the water has depleted. So yeah, once you click a certain area, you can either analyze it for the past 5 years. Right? What was the condition of runoff over the years, and was the evapotranspiration, what was the precipitation, and what is the water balance over the last 5 years. Or you can start planning for that area. Right? So we show the CLART map over here. On top of it, a drainage line is shown. Right? We are also showing the terrain of that area. Right? So we can analyze what uh, what are the good areas for recharge structures, right? And according to that, plan for a new recharge structure, right? We can also see the stream order and natural depression of that area, right? And like we can do the site analysis, or we can propose a recharge structure. So again, basically a certain set of questionnaire, and we can fill the form. A new recharge structure, a new demand for a recharge structure will appear over here. Right. Similarly, like in surface water bodies, also we provide option to raise maintenance with the yeah. So we provide option to raise maintenance for the remotely sensed water bodies and the water structures that has been marked in the resource mapping section. Okay. In agriculture, yeah, in agriculture we show the LULC map And so basically, we show the LULC map, and it shows like what was the cropping intensity over the past years. Uh, the color signifies if it was a single kharif, single non-kharif, double crop, or triple crop. Yeah. We can select a certain region, do a cropping pattern analysis, right? Like it shows the drought frequency over the past years and cropping intensity over the past few years, right? Like for 2023 or 2022. So this data has been updated till 2024. Yeah. Then we can raise raise for irrigation structure over here, right? Like you can click a certain area, see the clat map and terrain map, and decide for a new irrigation structure, which area is good for new irrigation structure, and you can just open the form, fill the certain questionnaires, and uh, raise a demand for new irrigation structure. Or you can if there are certain uh, irrigation structure that has been marked in past, you can just click over that and propose maintenance over that. Right. Similarly, in livelihood, we have like you can mark livelihood for kitchen gardens or uh, yeah. So basically, livestock, kitchen garden, fisheries, etc. You can raise demands for these. Maybe in agro horticulture, we can see the site suitability of the area. Like so, these are all green. Yeah. So we can see if the site is good. What are the climatic condition? What is the soil condition? What are the socioeconomic or ecology, other topography, right? But, yeah, and we can propose plantations over there. Again, this certain set of questionnaires that has to be filled, and we can use that to raise plantation demand, right? So yeah. So this was the online section of the application. We also support offline, like you can go to a certain region where there is no network availability, and you can just basically like download the maps, like pre-download all the maps, and you can just fill the forms over there also. So basically, like uh, uh, you create a new region. Uh, yeah. So you just let's say you want to go to Chhatra. Okay? So you basically mark a location. Basically, you pre-download all the maps, and yeah. So it basically pre-downloads all the maps, and you can just visit over there and use the whole application in offline mode. There is also a we require uh, login to use the application. So there is also like a demo login account which you can see from here. Like use these details and select this region, and you can use the test plan over there for like demo purposes or tests. Right. Yeah.
Cool. So Amit, on your question, right, how is it connected with the core stack? So basically, this is just an app built on the core stack. Yeah. The layers and everything that it uses are the same layers that we've been seeing, right? And similarly, all the indicators or any of the analysis. Yeah. So it's calling the same kind of APIs and pulling in the data. Right, but the purpose of the application is, of course, to enable rural communities to build up their own natural resource management plans. Yeah.
Yes, thank you. I just wanted to ask, Whether do you have something running continuously or in a manner that suppose you track the precipitation data on daily level, uh, daily basis. Does it get updated to the to these layers and does it compute everything? Um, I, um,
Mhm. So right now, actually, it is not a live update. Right now, most of the use cases that we were looking at were sort of about um, using the data to understand whether some area is drought prone or not, right? Or uh, in general, what is the average rainfall that area gets, right? So that is why we have not been doing live updates. But we will soon be starting out on that as well. Yeah. So now we are moving on to being able to build out use cases of weather forecasting. Yeah, that so that farmers can use that for some actions that they can take, right? Irrigation or pest control and so on. So we will soon start doing that. Yeah. But right now, the data, the LULC, for example, we are only updating once a year. Yeah. Some data we update on a 6 monthly basis by getting fresh copies of the data. Yeah. Um, but we'll soon be starting out on this live update as well. Yeah.
yeah, okay, thank you.
Yeah. Um, yeah. And S has a question on style files. So again, these are important points actually that we need to be improving. Um, So we actually decided it might be better, but maybe it was not such a good decision. So we have been giving, in some places, we've given three style files. One for what we call LUSC level one, which just has broad classes like water, built up, um, greenery, barren. Yeah. Then there's an LUSC level two, which sort of goes deeper and it breaks up greenery into trees and crops. Then you have LULC level 3, which goes deeper into seasonal. So the style file that you have, S, is level 3 actually. The data is there in the raster, but the other things are kind of masked out. So I would just say, if you can just drop us a message on the Discord channel or on email, we'll figure out how to get the full style file to you, right? With the full 11 classes. But of course, if Nursery or anyone, right, you can also put it on the chat if you have the link handy.
Yeah,
Yeah,
yeah.
cool. Yeah. So, okay. So this is the 12 class or 11 class LULC. Um,
So yeah, if you just download the style file from the stack page, it'll already be level 3. Just I mean, because I mean, yeah. So
mhm.
there won't be any other one. So in case, yeah.
Okay, yeah, yeah. Okay. So that's the difference. That on the download page is actually three different levels. Each one is published separately. But on the stack spec, the full style file is there. So we can just get it from there in one place. Oh, it seems my screen share is still on. Okay. Cool. Um, Great. Any other questions? Okay. Cool. So then let's stop the call now. And yeah, so feel free, to write on the various channels and um, yeah, let's try to build up some of these ideas. Um, all right. Okay. Uh, Thanks everyone.